Assalamu alaikum. A Pearson's chi-square test is a statistical test for categorical data. It is used to determine whether your data are significantly different from your expectation. There are two types of chi-square test: the chi-square goodness of fit test and the chi-square test of independence. Here we will discuss about chi-square goodness of fit test. It is used to test whether the frequency distribution of a categorical variable is different from your expectation. Suppose there are 5 bags. Each bag has 10 pieces of candy of 5 flavors. We expect to have equal number for each flavor. That means we expect 10 over 5 equal to 2 pieces of candy in each flavor from each bag. So each flavor of total candy is 2 multiply 5 equal to 10. For 5 bags, the observed and expected result are shown in the table below. Do the proportions of 5 flavors in each bag are the same? Use 5% significance level. First of all, we need to state null and alternative hypothesis. Null hypothesis state the proportions of 5 flavors in each bag are the same. Alternative hypothesis state the proportions of 5 flavors in each bag are not same. Now, this is our chi-square distribution. This region is our rejection region. Since the level of significance alpha equal to 5%, so value of this rejection region is 0.05. Rest is accepted region, which is 0.95. Now we'll find this critical value. For that, we need chi-square table. Here, we need to determine degrees of freedom, which is n-1, where n is the number of categories. Here, categories means number of flavors, which is 5. So our degrees of freedom is 4. Since the level of significance alpha equal to 0.05, so these two values meet at this value, which is 9.488. So our critical value is 9.488. Formula of chi-square test is summation of O minus E whole square by E, where O is observed frequency and E is expected frequency. Now we calculate this equation for each categorical value. Putting these table values, we get this equation, which is 3.4. These values lie on this accepted region. So we accept null hypothesis. That means the proportions of 5 flavors in each bag are the same. Now we'll discuss about chi-square test of independence. The chi-square test of independence is used to test whether two categorical variables are related to each other. Let's solve a problem. An agriculture researcher wants to test the effectiveness of a new insecticide. For that, he sprayed insecticide on 26 of 50 fields. The results are shown in the following table. Use 1% significance level. First of all, we need to state null and alternative hypothesis. Null hypothesis state insecticide doesn't restrain insect. That means insect is independent of insecticide. Alternative hypothesis state insecticide restrains insect. That means insect is dependent on insecticide. This is our chi-square distribution. This region is our rejection region. Since level of significance alpha equal to 1%, so value of this rejection region is 0.01. Rest is accepted region, which is 0.99. Now we'll find these critical values from where rejection regions start. For that, we need chi-square table. To find values, we need to determine degrees of freedom, which is r minus 1 into c minus 1. Where r is number of rows and c is number of columns. For this table, number of rows are 2 and number of columns are 2. So our degrees of freedom is 1. Since level of significance alpha equal to 0.01, so these two values meet at this value, which is 6.635. So our critical value is 6.635. Now this is our chi-square test statistic. Where O is observed frequencies and E is expected frequencies. These values are our observed frequencies. So we need to determine expected frequencies. For that, we need to determine contingency table. To determine values, we will apply this formula in each cell, where R is row total, C is column total, and N is grand total. For the first cell, row total is 26, column total is 24, and grand total is 50, which is 12.84. Now we'll continue this process in each cell. We get 13.52, 11.52, and 15.6. Now we'll apply this formula. These values are our observed frequencies, and these values are our expected frequencies. Now we put these values in this equation. We get this equation, which is 20.68. This value is greater than our critical value 6.635, and it is lie on this rejection region. So we reject null hypothesis. It means if we apply insecticide, it restrains insect. Thank you for watching.